Namaste, welcome to EPG Pathshala. In today's module, I am going to discuss about introduction to RDBMS. So, in this session, learning objectives are RDBMS introduction, RDBMS terminology and database design. Let us start one by one. Though we learn file system and it is very helpful, but file system has some limitations. These limitations include many things, like say for example, when file size is increased. So, working with flat file can be very slow, and if you want to search any record, it is very difficult because you cannot write query as you write in RDBMS. Though file system provide locking mechanism, but simultaneous access of the record is problematic, and in file system file processing is sequential. So, insert a new record or delete an existing record, that process make large overhead, and it is a special case in very large file, and there is a not sufficient different levels of access to data, only you can give access level to file only. While RDBMS, which is stands for Relational Database Management System, has many advantages over file system. The first one is that RDBMS can provide much faster access to data compared to flat file. The reason is that their data is not sequentially processed, but it will be directly taken and query can be written. Then as I say, query can be written. So, we can extract or retrieve specific set of records. Then RDBMS have a built in mechanism. So, no need for worry about simultaneous access of records, and it provides random access data, and RDBMS is a built in privileges system which facilitate different level of access to the data. So, your security is very easy and it will be easy to maintain as well. Now, RDBMS is actually concept developed by Dr. E. F. Coad in 1970, and he proposed this model. Based on this model, the relation database come into the picture, and nowadays Relational Database Management System or RDBMS is a de facto standards for many database centric applications. In this RDBMS terminology, I will discuss about table, column, row, value, constraints, schemas and relationship. So, in RDBMS there is a concept called table, or let me give you differentiate that how RDBMS is different from file system. Let us say take one example. For example, there is a file, take the general analogy. In file we have file of living certificate. So, each student has a living certificate, one student's one living certificate, second student second living certificate, etc. Now, in living certificate, student's name, their GR number or general register number, when he enter the school, when he pass out or going to another school, and reason for leaving the school, etc. The value will be different, but these characteristics or I can say property are same for each school living certificate. When it is converted into table, so table is a two dimensional structure which is consist of rows and column, and here these characteristics are written as a column like student name, student date of birth, etc., and each student detail is considered as a one record which is in horizontally, while columns are in vertical way. So, relation database is a consist of relation, and relation is also known as a table. Of course, there is a difference between relation and table, because every relation is a table, but each table is not relation. The reason is that to become a relation there are certain properties a table has to follow, like there should be unique column name within a table, then their column values must be a particular set of values, or we can say particular domain values. Then there should be either attribute or column or set of column value which uniquely identify a record, and sequence is not important in a table. So, if these all properties are satisfied, then a table become relation, but though in general term the word relation and table is used interchangeably, and a table is structure made of rows and columns. Now, this is example of table. So, the table name is customer. which has 4 columns. The columns are customer ID, name, address and city. So, customer ID is a one column, name is another column, address is third column and city is a fourth column, and this is the first record. So, customer ID is 1, name is Anand Mehta, address is this and city is this. Of course, it is just to give idea, otherwise name is not proper, because name should be subdivided is a first name and last name to work proper way in RDBMS. This is the second record Bhavesh Rajveer, this is the third record and fourth record. So, this is example of table. Now, in table has a rows and columns. So, each column in table represent different piece of data. For example, in the previous table we have seen customer table which has 4 columns, customer ID, name, address and city. Every column in a table must have a unique name. So, in a single table 2 columns cannot have same name, and each column is associated with precise data type, like here customer ID is a number, while name is a string or we can say character set type of data, same way address and city, and column is also known as a field or attribute. So, each row in the table represent a record. For example, in the customer table there are 4 customers, because these are the name of customers in this table. Of course, it is not necessary that there must be number of column and number of records are same, but in example we take 4 columns and 4 records, and row is also known as a record or tuple. Each row consists of collection of individual values, and intersection of rows and column is known as a cell, and each cell represent a single value. Each value must have its data type as specified by its corresponding column. So, for example, in this 1 is a value, Anand Mehta is a value, this address is a value. So, these all are values and this is cell. This is the first row first column intersection, say this is the second column first row intersection, and where we written name, and value of name is Anand Mehta. So, this is the value. Now, let us say constraint. So, in detail I will explain, but to give brief idea, a constraint is used to restrict the type of data which can be stored in a column, and constraint can be column level or table level, and there are many 4 types of constraints support in MySQL. These are the primary key, foreign key, unique and not null. So, you wonder what is primary key. So, as I say, in relational database the name given because there is a relation between tables, their relation established by using the concept primary key or unique key and foreign key. So, to decide a uniqueness there is a primary key. A primary key is used to uniquely identify a record in a table, and for that a attribute or set of attribute is used, and this attribute is known as a primary key. If it is only one attribute, then it is a primary key. If it is more than one attribute, then it is known as a composite primary key. Primary key consists of set of attribute. For example, in the customer table customer ID is defined as a primary key. The reason is that customer ID is uniquely identify a record. Of course, you can choose name, but it may possible that when new customer are added their name may be same. So, you should keep in mind that primary key should be choose such attribute which will be helpful to uniquely identify a record. Primary key is used to maintain entity integrity. Entity integrity ensures that the value of that particular column is unique, and no part of primary key will not contain null value, or another way I can say it will not be it will be not null value. Entity integration ensure that attribute must be unique within a table and cannot be null, and table has primary key defined. So, it is referred as a, that means, if a table has a primary key defined, so that table is known as a master table or parent table. Now, foreign key is used to define the relationship. So, in relation database there is a relation between tables of the database, and relationship between tables is defining using foreign key. For example, customer ID is a primary key in customer table, and in order table we can use customer ID as a foreign key. Foreign key is used to provide referential integrity between tables. Referential integrity means it support that it can give you only either null value or only those value which is available on their parent tables. So, it maintains the referential integrity. So, attribute can take only value available in parent table. For instance, consider we have an order table, then in order table only those customer can place order which are available in customer table. Like in our previous example, we have customer ID 1, 2, 3 and 4 only. So, out of only this 4 value 1, 2, 3, 4 any value you can take multiple times. Of course, you can take multiple time, but you cannot take 5 or 0 or any other value. The table in which foreign key is defined is known as a child table or detail table. This is just a representation of primary key and foreign key. In customer table, customer ID is a primary key, and in order table customer ID is a foreign key. It may happen that not all the customer ID of parent table will be used in child table, but value must be from the parent table. It is referring that value, that is why it is known foreign key and reference that value. Now, come to database schema. So, the table design with attribute name, primary key and foreign key attribute is known as a schema of a table, and the complete set of table schema is considered as a database schema. For example, this is the customer relation with attribute customer ID, name, address and city, and customer ID is a primary key. So, it is represented by underline. Relationship in database table can be assigned. So, this database is known as a relation database, and as I said earlier, foreign key is used to set relationship between data of two tables. And now, relationship mainly three way, either one to one, one to many or many to many. One to many is a most general, like in our previous example we take customer and order. So, it is one to many relationship, because one customer can order many item. One to one is means that both the table have matching primary key, and it is says that if there are one to one relationship, you can combine only in one table. Say for example, bank account number and customer. So, if there is a bank account number, so it will be referred to only that customer only, and in one to many we can say one customer may have many bank account number, because one customer can have many bank accounts. So, it has many bank account numbers, and third one is many to many relationship. So, I give just example of authors and books. So, one books has many author, and one author can write many books. So, this is many to many relationship. Generally, to write many to many relationship, there is a required linking table, because many to many relationship is represented by in RDBMS by two one to many relationship with a linking table. Now, when you design database, so what you should think? So, generally database design is done by either database designer or a database specialist, and database design affects the way SQL work with database. In a organization where thousands of user, it is generally designed by a specific database designer, but for small or medium web application development, it can be designed by a web developer or any programmer as well also. A relation database system should model the real world environment where it is used. So, the job is a designer to analyze and map real world environment into relation database system. So, it depends what environment you are working, and then the design is come into picture. To model a database and the relationship between relation after a real world system, an ER diagram, entity relationship diagram or ER modeling is used. Database design is consist of 6 steps. These steps are: first is recognizing data elements, then subdivide data elements into smallest useful elements, identify tables and assign the columns, find the primary key and foreign key, check whether the data structure is normalized, and identify the indexes. Let us discuss one by one. The first one is recognize data elements. So, to recognize data elements, because you have to map from real world entity to the your RDBMS way. So, there are many ways. If there is system already exists, you can study it, or you can take interview from users and gather information from that, and then recognize data elements. Once data elements are recognized, then you have to check that what are the data elements into smallest unit you require. Like say for example, if I say you cannot know what will be the use of that data in future. So, generally you should be make data element as small as possible. For example, if I write name, which is consist of name and surname, and now you in future you would like to search on name. So, that will be not give accurate result, but if you subdivide into first name and last name, so you can search on particular one component only. So, that will be required, and then you can identify tables and assign the columns, because you recognize the data elements. So, now you decide what will be become your table, because in real world the entity will be considered as a entity set will be considered as a tables, and the attributes or properties that will be become column of your table. In real world, entity set is transferred into table, and a instance of an entity set, or we can say entities, become a record. So, that will be transferred into tables and assign the columns, then find the primary key and foreign key to give the relation among them, then check whether the data structure is normalized or not, and finally, identify the indexes. Now, let us start with normalization. So, normalization is a step by step process to reduce the redundancy. The benefit or objective of normalization is to reduce the data storage, and database should be effectively give you value. So, it used to reduce data redundancy and anomalize. There are various normal forms in normalization. They are known as a first normal form, second normal form, third normal form, BCNF, or Boyce-Accord normal form, fourth normal form, fifth normal form, and latest one is domain key normal form. But all these are not required. Generally, in real life up to third NF is sufficient. Of course, it depends on application, but most applications are generally go to up to third level. Now, as I say, anomalize also. So, let me give this some more concept about what are the keys and functional dependency to convert an unnormalized table into a normalized table, or unnormalized database into normalized database. So, key is an attribute or set of attributes which determines other attribute or attributes. If you know the value of attribute say A, then you can determine the value of attribute B. So, this is known as a, here A is a key. Then another definition is functional dependency or FD. So, functional dependency is the value of attribute or attributes determines the value of another attribute or attributes. If the value of attribute A determines the value of attribute B, then it is said that A functionally determines B, or you can call A determines B. In that case, A means left hand side attribute or attributes is known as a determinant or functional determinant, and B means the right hand side of right hand side attribute or attributes is known as a dependent or functional dependent. Now, there are characteristics required for each normal form. So, if a relation is in first normal form, then table it should be in tabular format, there should be no repeating groups and primary key is defined. In second normal form, it is already in first normal form and it should be fully functional dependency are there, and in third normal form, it is already in second normal form and there should be no transitive dependency. That means, second normal form is already in first normal form third normal form is already in second normal form and plus additional this things. So, as you move from first to second, second to third, it will become better and better. This is, I take one example. So, this relation has been given here with attributes order ID, order date, customer ID, customer name, customer address, product ID, product description, product finish, unit price and order quantity. So, this is unnormalized, and as it is unnormalized, there are some data redundancy as well as anomalized also. So, what are anomalized? So, there are three types. Anomalized means undesirable side effects. There are three types of anomalized. The first one is, I can say, insertion. What is insertion anomalized? Say for example, there is a new product is available, but any order has been not available for that product. So, for this relation there should be some primary key. Let us say for example, the primary key is order ID and product ID. So, this is composite key. Now, primary key cannot take any part of primary key cannot take null value. So, only new product is available, but order is not available. So, that record is not inserted. So, this is insertion anomalized. Second is deletion anomalized. Say for example, if I want to delete this record number, let us say 5. So, I also delete all the information of their description, their finish, the product finish type, their price, etc. And third one is updation anomalized. So, that means if you want to update any value, you have to update in all the instances of in a table. Say for example, if you want to change the price of sofa set, so that should be reflected in whenever within this table. Of course, through SQL query it can be done, but these are the anomalized, and as you progress from first to second, second to third, the anomalized will be reduces and you can get better database. Let us say for example, how to convert this unnormalized data into first normal form. So, there are not any multi-valued attributes, means this attributes has only one value, there are not more than one value, or I can say comma separated value. Like as in previous example, for giving idea about table, I write first name and last name combined. Here there will be only a single value, and every attribute is atomic, that means only one value, and primary key is defined. If all these three are satisfied, then your table or your relation is called in first normal form. If all the relation of your database is in first normal form, then your database is in first normal form. So, to convert it, the easiest way is that you can make the table structure, like say for example, this is the unnormalized, and now we put the value here with order ID, order date, customer ID, customer name, address, product and etc. So, this is in first normal form, and here we define primary key as a this all are the FD available, because order ID and product ID. If you know order ID and product ID, you can determine all other attributes. So, this is become your primary key, order ID and product ID composite primary key. Another approach is that if it is your table, then you can convert it into two tables. The first table is all the non repeating value, that means your first table with order ID is a determinant which determines order date, customer ID, customer name and customer address, and second table has a I can say product ID and primary key of your first table means order ID. So, order ID and product ID combined determine product description, product finish, unit price and order quantity. Both the approach are correct. You can use whatever approach you like to convert into first normal form, but this is in our first normal form. Now, though it is in first normal form and this is our FD, again it is a anomalized insertion, updation, delete. We have to convert into second normal form. Now, in second normal form says that the relation must have fully functional dependency. So, what is fully functional dependency? So, fully functional dependency means if attribute B is functionally dependent on key A, but not on any subset of key A, then attribute B is fully functional dependent on attribute A. in short we can say that it should not be partial dependency. It is generally occur when there are a composite key. If it is composite key, then it must be totally or fully dependent on it, not partially. So, in that first normal form to convert second normal form, we know that if I know customer product ID, I can get detail of product description, product finish, unit price. I do not require order ID for that, as in our first we define order ID here. So, here if I know product ID, I can get product description, product finish, unit price. So, this is partial dependency, because I do not that order ID does not require to determine this value. So, to convert in fully functional dependency, that table converted in that way: order ID determine order ID, order date, customer ID, customer name and customer address, and product ID determines product description, product finish and unit price. But order quantity, you must require order ID and product ID both, because it is not partial. If you know both the attributes, then only value, then only you define order quantity values. So, this is now fully functional dependent. So, from this relation converted into three relation, we just give name. First one is order, product and order underscore product, and these are the, to give you idea, put this value here, and now you can say you can add new product here, though it is not order by any customer. Even you can add any customer also, if he sorry, customer you cannot add right now, but product you can add, as now it is in second normal form. Now, again there are some problem of anomalies, like say for example, as I say here, if I know order ID, then I know customer ID, and if I know customer ID, I can get customer name. So, this is known as a transitive functional dependency. It is not a new concept. I give one example. Transitivity means if I say Mahesh is taller than Ramesh and Ramesh is taller than Manish. So, it is obvious Mahesh is taller than Manish. So, the same way here, if attribute A is functionally determine attribute B and attribute B functionally determine attribute C, then attribute C is transitively functional dependent on attribute E. So, here in this relation second normal form, there is a transitivity here, because if you know order ID, you can know customer ID. If you know customer ID, you can get customer name and customer address. So, it should be removed in third normal form. So, if you remove it, so you have get all this relation. The first relation is product ID with product description, product finish and unit price, customer ID with customer name and customer address, order ID with order date and customer ID, and order ID and product ID determine order quantity, because here customer ID will become here foreign key and here it become primary key. So, this is in third normal form. The four relation consist customer, product, order and order underscore product, and it will be free of most of anomalies there, because there are only one composite k here only, right. So, this is our original relation, and when we converted into third normal form, it will be consist of this four relation, and it provides good facility to write query as well as free of anomalies, and good database design is very essential when you want to work with database. Now, you sometimes require to use indexes also, because to search from the database you have to either scan the whole the database and then you have to find out particular record, but when database is very large, you should use it speedy. So, you can create index also, and index should be created for the column which is used as a foreign key, or any column which is used frequently in search condition or join, and has a large number of distinct values and is not updated frequently. I will show you some of the thing that how we define foreign key and how we can join two tables in next session, but this is for simple that any which column we should use for index. So, column which has foreign key and frequently used in search condition, large number of distinct value. Like say for example, it is not good idea to create index on gender column, and because gender has only two distinct value, male and female, and if an index consists of more than one attribute, then it is known as a composite index. So, let us summarize today's session. We know that relational database management system is one of the de facto standard nowadays for data centric application, and then we learn about RDBMS terminology, which consists of table, row, column, values, schemas, and how database design can be created, and how use normalization to work with that. These all are the references I am using, and thank you for watching. In next lecture, we will continue with RDBMS concept. I hope you are enjoying this session. Thank you.